All right, so this video is on electrical discharge. So discharging electrically charged objects is all about what happens, or how do these objects get rid of a charge once they have them. So that's what we're going to talk about here. So discharging a charged object means neutralizing it by removing, excess or extra charge. Okay, there are 4 methods to do this, to remove the extra charge. One is called grounding. We looked at that quickly when we talked about induction. Discharge at a point, exposure to humidity, and exposure to light. So we're going to go through each one of those quickly. So the first method to discharge is grounding. So in this case, objects must be connected to the ground, earth, by a conductor. Okay? So when we talk about grounding, it means that the charges are shared between the object and the earth. But because the earth is so big, it does not get charged. You don't see any difference in the earth. Okay, so when we talked about grounding by induction, it's actually exactly what it sounds like. We're getting those electrons to move into the ground, where it can spread out among the whole earth, and we don't notice a difference. So some examples, you can sometimes see grounding straps at gas pumps. And electronics workers wear an anti-static bracelet that's attached by a wire to a grounding system so that they don't get charged. All right, second one is discharging at a point. Okay. Smooth spherical objects hold charges indefinitely because the charges can distribute or spread themselves out evenly around the surface. But if we make a point, the electrons get so close together that they actually repel each other and fly off, just like in this diagram here. So the electrons get closer and closer together at the point, and then they want to basically repel each other and fly off into the air. So if you want to copy that diagram in some way, shape, or form into your notes, that helps. Okay, this picture is also straight out of your textbook, so you can get it from there too if you'd like. All right, so example, static wicks on an airplane. So if you've ever been on an airplane, or next time you're at the airport, check out these little points. These are called static wicks, and what they do is, as an airplane is flying through the air, it generates a lot of static electricity. A lot of friction between the air and the plane means that there's a lot of electrons that build up on the plane. So that can be actually quite dangerous. So you can get quite the shock if you touch a plane. So what happens is while the plane is flying, these electric charges can actually fall off of these static wicks, just like they do in this diagram. So that by the time the plane lands, it doesn't actually have that much of a static charge. All right, exposure to humidity is the third way to get rid of charge. So water molecules in humid, moist air act as a conductor and allow for the transfer of excess charge. So that's why you don't see much static cling happen in the summertime, because there's lots of humidity in the air to disperse that charge. But in the wintertime, when you take your hat off and your hair stands on end, there's no moisture in the air to get rid of that static charge in your hair. So that's why your hair stays staticky for a longer time. And then the last one is exposure to light. So exposure to light particles, which are photons, can also knock electrons off of an object. Now you don't really need to know how this works. You don't really need to have a diagram of it. You should have definitely a diagram for grounding and discharging at a point. But for this one, I mean, it's a little bit hard to draw a photon of light. So all you need to know is that exposure to light is another method to discharge an electrically charged object. All right, I have a couple of cool video clips about lightning that I will show you in class. But what I'd like you guys to do in class or at home, read page 410. It's got a ton of information on lightning. And then you're expected to draw a series of diagrams to show how lightning is an example of electric discharge, okay? Include a written description in each diagram so that when you go back to study this for your test, you know what you looked at, and you can remember how lightning actually is one other method of electrical discharge. So hopefully you can get all those parts answered and filled in, and if you don't understand something, make sure to ask us in class.